Zawala again. Today we're going to be going over another section of the West African Examination Council's Senior Secondary School Examination Mathematics for Liberian School. Today we're going to be going over what we call Surds, which is radical. We call it radicals also. We're going to learn how to simplify surds. We're going to learn how to add, subtract, and multiply them. And we're going to learn how to solve equations involving. So, interestingly, Phil has observed that though this is not an objective of WAEC, WAEC continues to test students on this. So we have included some things from there. So basically, here's what a surd is. For example, we call this one a quadratic surd or a square root. We call this one a cubic surd or a cube root. And we call this an n root surd. So here are some properties. So for example, we see here, if I have the square root of a times b, I can separate them into the square root of a times the square root of b. And if I had, for any root, I can use any one of these properties. Then we have other properties on how we can convert from the form of a surd, a radical form, to one involving rational exponent. We call this n the index, and we call x the radicand. So basically, to convert from this form, the index becomes the denominator. Okay? And this is a basic rule. We're going to use this to solve equations involving surds or radical. So if I wanted to eliminate this n root, I'll raise it to the power of n. All right? And if I had just a quadratic surd, I can write that using rational exponents 1 over 2. Interestingly, for quadratic surd, we do not have an index in there. The index is understood to be 2. So you're never going to see an index here for a quadratic surd, okay? You have to understand that it's 2. One of the basic things we have to deal with is that how do we write a surd in the simplest form? So we say the radicand does not contain a perfect square or a perfect cube or a perfect nth root, and it does not contain a fraction. The denominator does not have a surd or a radical. We're going to talk about this last one a little in the other video. So how do we simplify this? We can write as a product and quotient. We can multiply, divide, or rationalize the denominator. But when it comes to adding and subtracting, we want to rewrite the surd so that it becomes like surd. Okay? So they have the same index and they have the same radicand. All right? And we're going to see how we do that. So here's my number 1. Our first problem we have here is simplify. And this is the expression we have. This was taken from WAEC 2011. This is number 3. So looking at this, we see that they are all different. It looks like we can't do anything about it. But no, we can. When I look at 12, and I want to do them separately. When I look at what I have here, if I took 12, I can rewrite 12 as square root of 4 and square root of 3. And I know that square root of 4 is 2. So what you want to do here is you look for 2 numbers such that one of which is a perfect square, if it is possible. So when I take 75, I see that, well, it cannot be divided by 2 because it's an odd number. If I divide it by 3, I get 25. And I'm glad with that because 25 is a perfect square. Square root of 25 is 5. So it's 5 square root of 3. I'm seeing a radicand of 3. So that should give me a little hint into thinking about dividing this also by 3. Because if that is the case, then that's good. So if I divide 48 by 3, I get 16. So just seeing this 3 led me to divide it by 3 immediately. So 3 times 16 is 48. So now the square root of 16 is 4. So I have 4 square root of what? 3. So I can now use this information to rewrite what I have. So over there, I have 5 square root of 12. Or square root of 12 is basically what? 2 times square root of what? 3 minus 4. Square root of 75 is basically what? 5 square root of what? 3 plus 3. And then square root of 48 is the same as what? 4 times square root of what? 3. Now, 5 times 2 is 10. I have 10 square root of 3. Minus 5 times 4 is what? 20. I have 20 square root of 3. 3 times 4 is 12. I have 12 square root of what? 3. So I could do many things here. I could add the positive one first. 10 plus 12 is 22. So I will have 22 square root of 3 minus 2 square minus 20 square root of 3. So we have like radicals, like a 2a, like 22a minus 20b, for example. So what we do is to keep the surd, and 22 minus 20 is going to be just what? 2. So we are done. We have to simplify this. Okay, good. I can see that when I divide this by 2, I'm going to have 64 and 2. Now 64 is good because 64 is a perfect square. The square root of 64 is going to be 8. So this transforms into 8 square root of 2. So I'm going to write here 3 over 4 times 8 square root of what? 2 minus. Now if I take 32, now again, seeing that I have 2 here as a radicand, I can always test to see whether that's going to be divisible. That's going to divide this, and whether it helps me further simplify this. Yes, well, when I divide this by 2, I get 16. When I take the square root of 16, I have 4. So I have 4 square root of 2. So now instead of 32 here, I'm going to be having 4 square root of what? 2 minus 1 over 5. Now, then I take 50. Well, again, I'm led to divide it by 2. When I do that, I have 25 and then what? 2. What's the square root of 25? 5. I have 5 square root of 2. So then over here, I have 5 square root of 2. So what do I see here? I can do several things. I can do 3 times 8 is 24 divided by 4 is 6. I can do 8 divided by 4 is 2. 2 times 3 is 6. So I have 6 square root of 2 minus 4 square root of 2. And then here, these 5 can cancel. But remember, I have 1 square root of what? I have 1 square root of 2. So what do I have now? I have like radicals. Each one of them have a square root of 2. So I can add what I would call the coefficient. So 6 minus 4 is 2. 2 minus 1 is 1. So I can do 1 square root of 2. Better still, I can just do my answer as square root of what? 2. Okay? So let's go on to more challenging problems. Let's go on to number 3. Well, in a problem like this, is to first of all recognize that we have a quadratic surd. We can change this to a rational exponent, and that's what I'm going to do. Rational. Well, this is the same as saying 1 over 2. Remember, because if you don't see it, the index is going to be what? 2. Now, how can I get rid of half? What can I multiply half by to get 1? Well, by the reciprocal of half, which is going to be 2. So if I square this, let's say I have to do the same thing to the other side. And half, those will cancel. I'll be left with what? 3x plus 4 equals to 5 squared, which is what? 25. And then I can come over here and do 3x plus 4 equals to 25 minus 4 minus 4. I have 3x is equal to 21 divided by 3 divided by 3. X is equal to 7. And I can go and test it. I'm going to test it up here. Let me just check right up here. So what I'm checking, I'm going to do 3 times 7 plus 4. And I want to see what it's going to give me. So 3 times 7 is 21. 21 plus 4 is 25. When I take the square root of 25, I have 5. 5 is equal to 5. And so I know my answer was correct. All right. So this was solving equations. And this was a problem taken from WAEC, Liberia, 2006. It was problem number 45. The first thing is basically, if it is possible, let us isolate these radical over here. So what we're going to do here is the first thing, divide by 3 and divide by 3. Well, we could have done it that. We could have kept it like that and do it, but let's do it this way. So we cancel this. So what we're going to have here is going to be what? 2 minus x equals x minus 2 over 3. Now, I will convert that to a rational exponent, but I can also take another approach here. How do I get rid of a square root? To get rid of a square root, I must square it. So if I square that in, I will also have to square this. And then this is what I'm going to have. So the square root and the square will cancel. I'll be left with 2 minus x equals x minus 2 squared over 3 squared. And 3 squared would be what? 9. Okay? And let's see what could I do here. I can cross multiply, so I'll have 9 times 2 minus x to be equal to x minus 2 squared, which means x minus 2 times x minus 2. This is something, 9 times 2 is 18. 9 times x, that's minus 9x. This is going to give me x times x will be x squared. That's going to give me negative 4x plus what? 4. You can go ahead and practice that. And then now I have to bring everything on one side. So when I do that, I'm going to be moving this 18 here. I'm going to minus 18. Minus 18. I'm going to add 9x here. Add 9x here. This entire side is going to be 0. I have 0 equals x squared. Negative 4 plus 9 is going to be positive what? 5x. And what do I have here? That's going to be what? 4 and negative 18. That's going to be negative 14. So then I have to solve this. So let me see if I have another slide for the next page. Formula, but I can better still solve it by factoring and using a zero product property. So my factors here is going to be x plus 7, x minus 2. Because 7 times negative 2 is negative 14, and 7 plus negative 2 is 5. So then I have to solve this. X plus 7 equals to 0, or x minus 2 equals to 0. When I minus 7, I'm going to have x equals to 7. When I add 2, I'm going to have x equals to, so this is going to be minus 7, sorry. Yeah. Minus 7, x equals to negative 7. And then here, I'm going to have x equals to what? 2. But that's not done. So those are the two possible answers I have. I have to verify this answer to look for a extraneous solution. So if I go back to my problem, it was 2 minus x equals to x minus 2. Now let me take negative 7 in here and put it there, for example. I have 3 square root of 2 minus negative 7, that's going to be plus 7. And if I take a negative 7 over here and I put it over there, what do I have here? I have 3 times 2 plus 7 is 9. Square root of 9 is 3. 3 times 9 is 9. 9 would not be equal to negative 9. So this appears to be an extraneous solution. This is not a solution. So this is not a solution. Now let's try for this. So I'm going to do 3 again. Square root of 2 minus x equals to x minus 2. I'm going to do 3. Then I do 2 minus 2. And then I'm going to do 2, x is 2, so do 2 minus 2. 2 minus 2 is 0, square root of 0 is 0, 3 times 0 is 0, 0, 2 minus 2 is 0, 0 equals to 2. So the only solution we have for this problem of x equals 2 is the solution. It's the only solution. X equals negative 7 is an extraneous solution. It does not work. Again, we have to isolate the expression here containing the rational indices. So what we're going to do is we're going to add x here and add x here. So what we have here is 2x plus 5 to the 1 over 2 equals to x plus 1. And then we must get rid of the square. So I'm going to come down here so you see it clearly. So what I have is 2x plus 5 raised to the half equals to x plus 1. So to get rid of this half, I must square it, and I must square this also. So when I do this, it's going to cancel. I'm going to have 2x plus 5. And when I do this, it's a rule here that you've got to remember that, look, a plus b squared is equal to a squared plus 2ab plus b squared. Now, if you don't, then you have to do x plus 1 times x plus 1. But using this, I'm going to have x squared plus 2x plus 1. And then I have to move everything on one side, use a zero product property and solve. So I have minus 2x from here, minus 2x from there, and I'll minus 5 from here, and I'll minus 5 from here. So I have 0 here equals to, this is going to be 0. I have x squared. 1 minus 5 is negative 4. So I have this. I can either solve this by factoring, or I can move the 4 on the other side and take the square root. Equals 0. I can add 4. Add 4. I have x squared equals to 4. Take the square root. Take the square root. X will be equal to plus or minus 2. So I have two possible answers. X plus 2, x minus 2. I must go back and test them to see if they work or whether one of them is an extraneous solution. So now I must test. So here's the problem we have. We have 2x plus 5, 1/2, minus x equals to 1. So I have 2. Say if I'm using x equals to 2 for now. So I have 2 times 2 plus 5 square root minus half, x should be equals to 1. 2 times 2 is 4, 4 plus 5 is 9. So this is like half the square root of 9 minus what? X is what? 2 should be equal to 1. Square root of 9 is 3. 3 minus 2, 1. 1 is equal to what? 1. So x equals 2 is a solution. Now let's test for x equals negative 2. So I'm going to be very fast with that. 2 times negative 2, that will be negative 4 plus 5 to the half minus minus 2, that will be plus what? 2, and we want that to be equal to 1. Let's see whether that works. Oh well, negative 4 plus 5 would be 1. Square root of 1 is 1. You have 1 plus 2 is not equals to 1. So this did not work. Let me make sure we have 2 times negative 2, that was negative 4 over there. And I have negative, that's positive 2. So I have 3 is not equals to 1. So negative 2, x equals negative 2 is not a solution. Okay? X equals negative 2 is not a solution. Alright, good. So that's fine. So x equals negative 2 is an extraneous solution. X equals 2 is the only solution. Again, this ends our discussion on this section of the WAEC. This has been a production of FIELD. FIELD is the foundation for equity and excellence in education in Liberia. And a foundation organized by Liberians for Liberians to impact positively on the learning experience of Liberian students. We are committed to this work, but your contribution, your support really help us a lot in advancing, in improving the quality of our product and expanding to other areas. So please contribute. Please join us in expanding the work we want to do. You can do so by visiting us online at www.fieldliberia.org and make a contribution. Even if you don't do that, don't forget to subscribe to our YouTube channel. Follow us on Twitter, like us on Facebook, and please continue to send us your feedback. Send us your feedback to fieldliberia2015@gmail.com. Thank you.